Okay, so hi everyone. My name is Jan. For the last couple of years, I work like backend engineers on MOX project that Vacuumlabs helps to develop. Today, I would like to tell you something about what idempotency is and how it can help us to make sure that our systems are more fault-tolerant and resilient. So, first, let's look at an example. Let's say that we have a new customer that onboarded to our bank, and we would like to trigger a new process that creates a new card for them and sends it to their mailing address. Our example thing can look something like this, where first we create some kind of audit log that just marks that we started the whole process. Then we call some remote service that actually contains customer data, so we can use them to provide it to another service that actually knows how to issue our card. This can be some kind of third-party service, it can be other service inside our system, whatever. Once card is issued, we store its information inside our local database in card service, and then we mark our audit log so we know that customer already got the card. And at the end, we would like to tell our downstream consumers that card was created and they can do whatever they need to do with it. Of course, in reality, this doesn't always work as expected, especially our communication with many remote services is very fail-prone. Things fail, request time out, it's a mess. But we still have this business requirement that we should create card for every customer. So we want to start retrying our process if something fails. That, of course, brings some other category of issues. If we imagine that our call to issuing card failed and or timed out, we don't know if card was actually issued or not. We can retry whole process. Let's say that now it succeeded, but now customer may have second card. Now our process continues. We try to publish event, but Kafka is in bad mood today, so it fails again. We call issue card for the third time. Customer has 3 cards. It costs a bunch of money, and it's bad customer experience. So how can we fix that? Well, we already have retries that make sure that we create card at least once, but now we need idempotency to make sure that we don't make a card more than one time. As you may know, idempotency is this nice property that we can retry and retry and retry, and if our process completed once, it won't execute its steps again. So what do we actually need to implement this? First, we need to add some kind of identifier to our request or messages, so our services know if a request that they received was already executed, or it is a new request that they can safely run again. This whole thing must be idempotency key must be implemented by every service in our process. Otherwise, we cannot safely retry. Next, we also need some kind of mechanism that actually stores our result somewhere, possibly inside local database. So once our phase completes, one step completes, we don't execute it again. We just fetch results from the database and use them in next step, so we can safely reproduce every request. As a general rule of thumb, how we want to split this is every remote state mutation will get its own phase or own DB transaction, and then sequences of DB queries would be grouped together So we ensure that our data are consistent, at least in the local database. So this is updated version of our process. You can see that our post request to issue card service now contains additional parameter that is our idempotency key. We also added idempotency key to initial message that triggers the whole thing. And we kept issue card step in their own phase and also publishing event in its own phase, because those two steps actually mutate stuff outside of our service. But we can group together storing card and update and completing card creation, because those are just updates in our local database. So how does this impact our failure scenarios? First, let's say that a call to our issuer service fails. We can safely retry from the beginning. We won't create a new card creation record. We will use already fetched customer profile, and so we safely reproduce a request to issuer service. We also use the idempotency key, so issuer service guarantees to us that it won't create another card. Now let's say our process succeeded, and we continue again, but Kafka is not happy. So we can safely retry from the beginning again, but now none of the steps before is executed. We just fetch the result that we already have in the database and use it to produce a final message. So at the end, what we've hopefully learned today, data consistency in distributed systems is very complex. There are many approaches how to fix it. Idempotency and retries are there to help. However, they also bring additional complexity to our business processes and our implementation, because now we have to juggle all these atomic phases inside our business logic. So in our case, we extracted this code to a library that every service can use. And of course, designing these atomic phases properly is not always easy. And it's the responsibility of our developers to do so. And at the end, our database space will also grow, because we have to store all these intermediate results in our relational database. However, that is only temporary issue, because we don't have to keep those records forever. We can delete them periodically, once every couple of days. So that's it. I hope you learned something new. If you have any questions, don't hesitate to ask.